Hi and welcome. I hope everyone is okay. Now, in this lesson, we will pass the other topic. Our topic name is linear combinations of random variables. Why do we study linear combinations of random variables? We will learn. We have some example about linear combinations of random variables. In some problem solving situation, it's more appropriate to use a combination of random variables. For example, the weight of jar of honey is a combination of the weight of the honey, the weight of the jar, and the weight of the lid, which is combination of independent random variables. Another example, a triathlon time is a combination of the times taken complete different events, and the results of each event are independent random variables. The last example, in the monthly profit or loss of stock portfolio, the investments in stocks and shares in several companies are given as a single value. This value is actually the sum of profits and losses of the individual investments. And before I want you to remember something about the expected value and the variance. As you remember, we had worked out expected value is the sum of all x multiply probability. And if we want to compute the variance, our variance value is the sum of x square multiply probability minus expected values square. Okay. Now. The following dices as a fair six-sided have been given. Let the random variables x, y, q, and g be the scores obtained when the dice is rolled. Then the probability distribution for these are shown in the following table. Let's work out their expected values and variances each and compare. Okay, we have some situations about dices are rolled. The first dice is numbered 4 4 5 5 5 6. We have 2 times 4. We have 3 fives. We have 1 6, and the probability of 4 2 over 6, so 1 over 3. The probability of 5 3 over 6, so 1 over 2, and the probability of 6 1 over 6. The expected value, for the expected value, we should find the sum of all x multiply and their probability. So the expected value 4 multiply 1 over 3 and 5 multiply 1 over 2 and 6 multiply 1 over 6. And as I found the expected value 29 over 6. Okay, and variance, our variance is the sum of x square multiply probability minus expected value square. So as you remember, variance is 4 square multiply 1 over 3 plus 5 square multiply 1 over 2 plus 6 square multiply 1 over 6 and minus expected value 29 over 6 square. And as I found 17 over 36. Okay, 17 over 36. And the other situation, but the second dice is numbered 77889, and as we will find the probability, the probability of 7, 1 over 3, 8, 1 over 2, 4, 9, 1 over 6, and expected value 47 over 6, and variance 17 over 36. I want you to compare before example and the second example. For the first example, our dice is numbered 4 4 4 4 5 5 5 6 4 4 5 5 5 6. Okay, and if you notice that these values have correlation with each other. For example, 7 7 4 4 minus 3, 8 8 8 5 5 5 minus 3, so 9 and minus 3 6. So y means x minus 3, and the expected value y means the expected value of x minus 3. If you notice that for the first situation, expected value 29 over 6, but the 29 over 6, excuse me, y means x plus 3, so y is x plus 3. The first situation, our expected value is 29 over 6, but in the second situation, expected value is 47 over 6, and as you notice that 47 over 6 means 29 over 6 plus 18 over 6, and 18 over 6 also equals to 3. So finally we can tell the expected value of y or the expected value x plus 3 means the expected value x plus 3. So for the finding that the expected value x plus 3 means the expected value of x plus 3. Okay, and if you notice that variance value, in the first situation, our variance 17 over 36, and the second situation, our variance value the same. So if we add to another, if we add to any number on the first situation, the variance doesn't change. So the variance of x plus 3 also equals to the variance of x. So if we add or subtract to any value on the x, the variance doesn't change anytime. Okay. Now the second situation. In the second situation, our dice is numbered 2, 2, 3, 3, 4. So in the third situation, our expected value q, means 17 over 6. Our values means 17 over 36. As you notice that and compare the first values, are in the first example, our values are 4, 4. In the second, 2, 2. The first dices numbered 5, 5, 5, 3, 3, 3, and 6, 4. And as you notice that the third dice numbered about according to first dice, all number are the first dice's numbers minus 2. So q means x minus 2, and the expected value of q means the expected value x minus 2. And if you notice that the expected value q 17 over 6, the expected value x, I want to look at again. The expected value x 17 over 36, 17 over 36, 17 excuse me, 29 over 6, 29 over 6, 29 over 6, and if I subtraction to 12 over 6, I can find 17 over 6. And as you see this situation, 12 over 6 means 2. So we can find this result. The expected value of x minus 2 means the expected value x minus 2. Okay, and if we want to compare the variance about the first example and third example, the first example, our variance 17 over 36. The third example, our variance 17 over 36. So if we add or subtraction to any number, any number, the variance doesn't change. Okay. Now we have another problem. The fourth dice. Our fourth dice is numbered 8, 8, 10, 10, 10, 12. So the expected value of G is 29 over 3. The variance value G is 17 over 9. Please remember that For the first example, in the first example, our values are yeah 4 4 5 5 5 6. The fourth in the fourth example, all values according to first values times 2. 8 4 times 2. 8 means 4 times 2. 10 means 5 times 2 ve and 12 means 6 times 2. So G means 2 times x, and the expected value G means the expected value of 2 times x, and the expected value G means 29 over 3. The expected value x is 29 over 6. I want to look at again. The expected value x is 29 over 6. Okay, so 29 over 6 multiply 2 means 29 over 3. So we can find these results. The expected value 2x, the expected value of 2x means 2 multiply the expected value x. 2 multiply the expected value x. Okay, and variance, the variance value of G means the variance value of 2x. So the variance value of G 17 over 9, but the variance value of x, the variance value of x 17 over 36. 17 over 36. So 17 over 36, 17 over 36 multiply 4 means 17 over 9. So 4 means 2 square. 4 means 2 square. And 2 square, and the expected value, the variance value 2x means 2 square multiply the variance value x. 2 square multiply the variance value x. Please notice that if you want to find the variance value of 2x equals to 2 square multiply the variance value x. And another example, our values is these values, and if we want to compare the first values, please notice that these values we had 4, now we have 4 over 3. We had 5, now we have 5 over 3. And we had 6, now 6 over 3. Okay, and mean, if we want to G means x over 3. X over 3. The expected value G means the expected value x over 3. And the expected value G 29 over 18. 29 over 18. So the expected value, please remember that the expected value x 29 over 6, 29 over 6, 29 over 6. So 29 over 6 multiply 1 over 3 or over 3 doesn't change, over 3 or multiply 1 over 3 means 29 over 8, 29 over 18. So if we want to work out the expected value of x over 3 means the expected value x multiply 1 over 3. Okay, please remember that the variance g means the variance of x over 3. The variance g means 17 over 324. 17 over 324. Please remember that the value of x is 17 over 36. 17 over 36. 17 over 36. But if you 17 or if you multiply between 17 over 36 with 1 minus 9 becomes 17 over 324. So 1 over 9 equals to 1 over 3 square either. 1 over 3 square. So the variance of x over 3 means the variance of x multiply 1 over 9. Okay, now or we can find another such 1 over 3 square. So our finding that now I want to give some example, create myself, and for example the expected value x plus 5, the expected value of x minus 2, the expected value 3x, the expected value x over 2. If you want to compute these values, you should compute that the expected value x plus 5, the expected value x minus 2, 3 times the expected value x, and 1 over 3 times the expected value x. Okay, but if you want to something about variance, if you want to something about variance, for example the variance of x plus 5, the variance of x minus 4, the variance of 5x, the variance of x over 4. Okay, please notice that and don't forget, if you if you add or subtraction any number on the x, the variance value doesn't change. So the variance of x plus 5 equals to the same the variance of x. The variance value x minus 4 equals to the same the variance of x. But if you multiply 5 or if you divide it by 4, the variance change every time. So it means 5 square multiply the variance of x, 1 over 4 square multiply the variance of x. Okay, okay, and result, the finding of our results, the expected value ax plus b means a multiply the expected of x plus b. The expected the variance of ax plus b means a square variance of x. B doesn't change variance. B doesn't change variance. Only multiply a change variance. Don't forget. Okay. Now in our document also is written the expected value x plus b means the expected value x plus b. The variance value x plus b means also the same the variance of x. The expected value a multiply x means a multiply the expected value x, but the variance of a multiply x means a square the variance x. Okay. The expected value a multiply x plus b means a plus the expected value x plus b, but the variance a square multiply the variance of x. B doesn't change to variance. Okay. Okay, now we have some example. Give that a random variable x has the probability distribution shown in the following table. Find the expected value of 2x plus 3, the variance value of 2x plus 3. Beforely, we should find the expected value x. The expected value x means the sum of x multiply probability. So the 2 multiply 0.4 plus 3 multiply 0.1 plus 5 multiply 0.3 plus 7 multiply 0.2. So 0.8 plus 0.3 plus 1.5 plus 1.4, 2.9, 3.2, 4. Okay, 4. And the value of x means the sum of x square multiply probability minus the expected value of x square. So 2 square multiply 0.4 plus 3 square multiply 0.1 plus 5 square multiply 0.3 plus 7 square multiply 0.2, okay, minus the expected value square minus 4 square. So I want to write this area. This process 1.6 plus 0.9 plus 7.5 plus and 9.8 minus 16, and then 2.5 10 19.8 minus 16 becomes 3.8, okay, 3.8. But we want to find the expected value of 2x plus 3, the expected value of 2x plus 3. 2x plus 3's expected value means 2 multiply the expected of x plus 3. So our expected x value is 4. Our expected value 4. Our variance 3.8. Okay, and 4 2 multiply 4 plus 3 means 11, and we want to find the variance of 2x plus 3. And please remember that 3 doesn't act variance, plus 3 doesn't act or affect variance. Also 2 act to variance. So it means 2 square multiply the variance of x. So 4 multiply 3.8. 4 multiply 3.8. It means 15.2. Okay. Now we have another example. The random variable x is the number of tails obtained when 3 fair coins are tossed. Construct the probability distribution table for x and find the expected of x and the variance of x. Okay, now we want to obtain tail, and we will toss fair coin 3 times. Our tails may be 0 times, 1 times, 2 times, 3 times. 0 times the probability of 0 times hat. So 1/8. Okay, 1 times tail hat, or hat tail hat, or hat tail. So 3/8. 2 times tail, tail, hat, tail, hat, tail, and hat, tail, tail. 3 over 8, and 3 times tail, 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 1 over x. Okay, and the expected value means the sum of x multiply probability. 0 multiply 1 over 8, 1 multiply 3 over 8, 2 multiply 3 over 8, and 3 multiply 1 over 8, and 3, 9, 12, 12 over 8 means 3 over 2, and the variance means 0 square multiply 1 over 8 plus 1 square 3 over 8, 2 square 3 over 8, 3 square 1 over 8. So 24 over 8 means 3. Okay, now we want to find the expected value of 2x plus 1. The expected value 2x plus 1. The expected value 2x plus 1 means 2 multiply the expected value x plus 1, 2 multiply 3, 2 multiply, it's also 1 over 5. 2 multiply 1.5 plus 1, it means 4. And the variance value of 2x plus 1, please remember that 1 doesn't affect to variance, so it means 2 square multiply the variance of x. Excuse me, I have a mistake, because I should have made the variance of x means, the sum of x square multiply probability minus the expected value square. So I had worked out this process. It's also 3, but minus I should made 1.5 square, so 3 minus 2.25, 0.75. okay, 0.75. So we want to compute that 2x plus 1 of the expected value. So 2 multiply the expected value of x plus 1, it means 2 multiply 1.5 plus 1, it means 4. We want to find the variance of 2x plus 1. Please remember that 1 doesn't act the value variance, only 2 affect two variance. 2 square multiply the variance of x, 4 multiply 0.75, it means 3. Okay, now in this lesson finished. So the other lesson we will go on where we stay in this point. As now, have a good lesson and have a good day.